All right, so last week we finished up with vectors. Okay, and chapter 8 was really the last chapter that we learned any new trig. Okay, so chapters 9, we're going to see very little trig. Okay, it's nothing new. And by the time we get to end of chapter 9, section 9.4, there's no trig in that at all. And then in chapter 10, there's no trig at all. So we're almost done with anything we're going to do with trig. Right, today and tomorrow and Wednesday, we're going to look at graphing. Okay, we're going to look at how we can graph different kinds of shapes. The kind of graphing that we're used to doing is when you have y by itself. Okay, and we've graphed parabolas, we've graphed lines, we've graphed sine functions, cosine functions, all that kind of stuff. But there's all kinds of different graphs we can generate. Have we ever looked at anything that looked like that? Yeah, that's a totally different kind of graph. Okay, there's another one. Kind of looks like a butterfly a little bit. And here's one that kind of looks like a sine wave, but it loops back on itself. Right? So these are all different kinds of graphs that you can generate in what's called parametric mode. Okay? Different kind of graphing. Most of these are far more complicated than anything we're going to do. But you can really create some different kinds of stuff with parametric graphs. Right, so first I'll just explain what a parametric graph is, kind of how you set it up, and then we'll do some stuff on the calculator, basically changing the mode and typing it in. All right, so one of the big differences with parametric graphs is it's not just one equation that draws the picture, you need two. Right? So when you do y equals, you just type in one equation, that makes your picture. Okay, with parametric, you need two equations. And that's why we can get graphs that look so different. And what basically the two equations are is you've got one equation that generates all the x values in the picture, and then you have a separate equation that generates all the y values. Okay? That's how parametric works. Right, so one equation is going to give me all my x's. A different equation will give me all my y's. In this problem, I called function f. That's the equation that gives me my x's. G, that's the function that gives me my y's. And the other thing that's different about parametric is there's this thing we call an interval. Right? So most parametric graphs have a start point and they have an end point. When we draw functions like lines or parabolas, they go on forever. Okay? Parametric graphs do not. Okay? They have a beginning and an end. Now, sometimes it's hard to tell where the beginning and the end is, especially if they're the same point. Okay? Maybe this graph starts here, and then it goes down, comes around, and it ends there. Okay? In that case, you can't really tell the beginning from the end. But if we were to draw like a line segment, which we will, it'll have a beginning, and it'll have an end, and it'll look just like that. Right, so that's one of the first graphs we're going to look at, just how to draw a line segment. Right, so if you take all these ordered pairs, right, and graph them over this interval, we get what's called a curve. And the word curve is used kind of loosely here. Curve doesn't mean it has to bend. Okay, technically, a line segment we would call a curve. Okay, it's just the name, it's just a graph, it's a picture. Okay, it's a curve. Okay, and the two equations that help you to draw your curve, or the equations you type into the calculator, those are called the parametric equations for the curve. Okay, so you'll have one equation for x, and you'll have a separate equation for y. And you'll see when we switch it to parametric on the graphing calculator, it's going to look a lot different than when we had y equals. Okay, and the last thing is the variable that we use. Okay, like in y equals mx plus b. We have y and we have x. We usually just call them variables. Well, in parametric, they usually call t a parameter. Right? Parameter, variable, it's basically the same thing. Okay, the only difference I want you to think when you see the word parameter is there are only certain values you can use. Okay? And that's what defines our interval. Okay? The parameter, you can't pick any number you want. I will tell you for t, you can pick numbers, say, I don't know, between 0 and 5. Okay? Those are your parameters you have to stay between. Very rarely will we do a graph where you can pick anything for t. It's usually restricted. Right, so as I said before, a parametric curve, it has a start point and it has an end point. Okay, the start point and end point, it depends on what I tell you to use for the parameter. Okay, so just to show you an example, here's a pair of parametric equations, and I'm telling you that the parameter goes from 0 to 1. Okay? Based on it going from 0 to 1, that's going to control where my start point is and where my end point is. And this is also something you have to put into the calculator. You have to tell the calculator what's your start point for t, what's your end point for t. And you'll see there's going to be a new spot on the screen to do that. Okay, so the start point and the end point depend on the parameter. And suppose, in general, I gave you a parameter that started at A, ended at B. Okay, when we do a real problem, it's going to be numbers. Okay, to figure out your start point, this would be the start. You take the first value in the parameter, okay, whatever number that is, and you're going to plug that number into the function for x. Then you're also going to plug that number into the function for y. And that'll tell you your start point. So just to show you with an example, if I want to find my start point, I would plug 0 in for t in the first equation. That would give me my x value. And then I would plug 0 in for t into the second equation. That would give me my y value. Okay? And that's the start point, just using the 0. Okay. Then if I want the end point, okay, I use the second number in the parameter. Plug the second number into the first equation. That'll give you the x. Plug the second number into the second equation. That'll give me the y. Right, so in my example, I would plug 1 in for t. That would give me where the x values are going to end. I'd plug 1 in for t in the y equation. That tells me where the y's are going to end. Right, so there's really 4 calculations you need to do to find a start point and an end point.
Why for i's in brackets?
What does that mean if we put numbers in brackets versus, say, parentheses? Think about when we're talking about intervals. What do brackets mean?
In between.
Okay, it does mean between 0 and 1. Can be a little more specific than between. Yep.
Can be equal to 0 and 1?
Yeah, it can equal 0 and 1.
I don't know, that was just an order operation.
Nope.
Stuff like that.
So that's a closed interval. Okay, you can include 0 and you can include 1. Right, so we're just going to try to find the endpoints of that curve. We'll do it by hand, and then I'll show you how to type it in on the calculator. All right, does everyone have what's on the left? Okay. All right, in that interval, what value controls where my curve is going to start? The 0. Yep. So we're going to take and plug 0 into the first equation. And we're going to plug 0 into the second equation. I need to find those two values. One of them is the x, one of them is the y. So we have 1 minus 2 times 0 and 2 minus 0. Okay, let's start with the first one. Okay. 2 times 0 is 0, and 1 take away 0 gives me 1. And how about when I plug 0 in the y equation? 2. That's the start point of my curve. 1 comma 2. So when we're sketching it on the calculator, you're going to see it start at that point, and it's going to draw towards my end point. What value am I going to plug into both these equations to find the end point? 1. Okay, fill in 1. Okay, so it's going to give me 1 minus 2 times 1 and 2 minus 1. Hey, Nick, what's 1 minus 2 times 1? Good, -1. And Amanda, 2 minus 1 gives me 1. Okay, so there's my endpoint. -1, 1. Any questions on that? All right, now let's try it on the calculator. All right, so first thing we have to do is change the mode so it's not in function anymore. We're going to change it to parametric. Okay, so just press mode. Put it on parametric. And now once you set it on parametric, press the y equals button. Okay, but now it looks a little different. Okay, it shows there's an x and a y equation for each graph. Okay, and that's where we're going to type in our two equations. Okay, so for the x equation, try 1 minus 2t. That's 1 minus 2. And now you might be like, well, where's t? The button that used to be x is now t. Okay, when you change it to parametric, it's a t. Okay, so we got 1 plus 2t, and what was my other equation? Oh, it was 1 minus, sorry. Minus 2t and 2 minus t. All right, so now that's just your equations. We still have to put in this interval. Okay, to do that, we're going to go to Window. What do you notice there that we didn't have before?
T.
Yeah, all the stuff with t. T min, t max, t step. All right. T min is the lower value in my interval. T max is the higher value. So we're going to start at 0. Mine's already there. We're going to go to 1. And for t step, put it on 0.1. Okay, I'm going to explain in another problem what t step does. This isn't the best problem to explain t step. Okay, just put it on 0.1. Now, make sure your coordinates of your endpoint are going to be in that window. They are. Okay, I got to be 1, 2 for my start, and -1, 1 for my end. So you know what? Let's make the window a little smaller. Make it -5 to 5. Okay, on everything. This is just to show you the picture a little bigger. So -5 to 5. -5 to 5. Now, as you hit graph, I want you to watch the direction it draws it in, okay? Because that's something you can only see as it's actually sketching it. Right? So it should start at the point 1, 2 and head towards -1, 1. And it did. Okay? It started in quadrant 1 and went towards quadrant 2. And that's it. Yep. This didn't work. Let's see. And you adjusted your window.
So what does the T min and T max do?
That controls where the sketch is going to happen. So for example, let's say I changed it from,
It's just like the start and the end, it's just like
yeah.
it gives us like a text or whatever.
So if you changed it from 3 to 4, okay, what would happen is your x value would start at 1 minus 6, which is negative 5. And and let's see, the y value would be 2 minus 3. So my graph would start there. Okay, if I put t min as 3, it would start at negative 5, comma, negative 1. So it just controls what portion of the graph you see.
Okay.
Yeah. And t-step is also important, but we're going to look at that in the next problem. All right, so sometimes what we can do is take t out of the equations. In other words, we can take it from parametric and change it back to what we're used to. Okay, y equals, and then a function of x. Okay, so we're going to take our first example, and we're going to try getting rid of t, okay, changing it back to a function notation. Okay, and when we're doing this, this is called eliminating the parameter. Okay, we're getting rid of t. Right, and first step to do it is to take your equation with x, take equation with the x, and solve it for t. Okay, get t by itself. So that's the first thing I'll do. Brian, can you tell me what my first step would be if I want to try to get t by itself?
Subtract 1.
Yep, I'm going to subtract 1. So that's good. So we almost have t by itself. Just one more step.
Divide by negative 2.
Yep, divide by negative 2. Those cancel. And I get t equals x minus 1 divided by negative 2. I'm just going to move this over a little bit. Right. Now I have a formula for t. It's x minus 1 divided by negative 2. Any thoughts what I'm going to do with that?
Plug in where t is
Yep, we're going to plug it in where t is in which equation?
in x or heading. Maybe next.
Not next, because we already used the x equation
Oh,
in y. Okay, we're going to take and plug that in right there.
where is y?
Okay, and then once we do that, we won't have a t anymore. Okay, we'll have a few fractions we'll have to simplify, but then that'll be it. So I'm going to have y equals, okay, and I'm just starting up here so I have a little more space, 2 minus, and now fill in for t. Make sure you put it in parentheses. Hey, any questions on that part?
So why are we putting in the y just to solve y? Or
So when we write something in function
solve for
notation,
x
yep.
first, and then we just probably got to find the answer for y.
Yep, because you want to get it with just x's and y's. Okay, x's and y's are how we're used to writing functions. All right, so we're trying to get rid of this t. All right, so first thing I got to do is distribute out that negative. So I get 2, and yeah, let's do it like this. Minus x plus 1 over negative 2. And now, instead of writing this part of it with a common denominator, all together. I'm just going to separate it out. 2. What's going to happen if you do negative x divided by negative 2?
Gonna be
Positive 2. So I'm going to write it as positive x divided by 2 is the same as a half x. And now 1 divided by negative 2 is negative a half. Right? And I'm just going to rewrite this in an order we're used to looking at it, and I bet you're going to recognize in a second what this is. It's y equals mx plus b. 1/2 x plus, what would be my y-intercept? Yep, 1.5 or 1.5. Okay, so what we just sketched parametrically was this line. We didn't sketch the whole thing. We only sketched a small segment of it.
So can you do y first and then use that to solve for x? Or do you have to solve for x first?
Well, oh, you mean solve for t in this equation?
Yeah, I mean, yeah, solve for t and y first, then use that to solve for t and x.
Yeah, that might work.
Either way, or do you just...
We could try it. We could try it after and see if it works. If you do it this way, what happens is you automatically get y by itself, and that's how you always want it. I have a feeling that it would work, but the problem is you wouldn't have y by itself. You'd have to rearrange it. Okay, so doing it the way I showed you, y is always by itself.
Why do you leave that as it goes y equals 2 plus half x? Why do you leave the 2 out?
The 2?
Yeah.
I mean, why didn't I divide that by negative 2?
No, like right below.
Yep.
You have a 2 there, but then in the y equals mx plus b form, you don't have
So this came from, oh, when I rewrote it, I combined like terms. 2 minus a half. 1.5.
2.
Yep. Just to get it y equals mx plus b. All right, so let's, let me just take this, put that there. Okay, so that's what it looked like when we did parametric. Okay, let me graph it in function. All right, so let's take our function. Okay, y equals, I'm going to type it in as 0.5x plus 1.5. Graph it. Okay, see what it looks like. Now, when you change back to function, notice how there's nothing here. Your parametric equation is still there. Okay? It's not going to draw it, but if you go back to parametric, it'll pop back up. Okay, so type in 0.5x plus 1.5. Okay, it kept the window exactly the same. I want you to compare these two and see if they look the same. Let's take. Okay, do they? What's different? Yeah, as a parametric, okay, it only drew part of the graph. As a function, it drew the entire thing. Okay, so they're not the same. Okay, this part is the same, but it drew more than it should have. Okay. Where was my x values? Let's go back to what we had. Where were my x values supposed to start at? Yeah, they're going to go from, it was 1, and where did they end at? -1. So we were only supposed to sketch this graph between -1 and 1. If that's the part you want to sketch, just put it in parentheses and tell the calculator to do that. Say, I want you to sketch it where x is greater than or equal to -1. But I also want it less than +1. Okay, I think we might have done something like that before. Just put the condition in parentheses, what you want. And now it's not going to be perfect, but this is the best that I can do. Right, so what it basically does is it has to it has to draw everywhere on the axis or up above it. So just ignore the part that's on the axis. You can't get rid of that. But now the part that's not on the axis matches what we had. Okay, my window might be slightly different because it looks a little bit steeper. As long as I typed in 0.5x, yeah, which I did. Okay, so those two graphs should be the same, and they are.
Can you go over that again? Like, why do we find such a almost
How we did what?
how we found that, like the signs?
So we solved
Yeah, we saw.
for t,
Yeah.
and then we plugged it in to the y equation.
Yeah.
And we got 1/2 x plus 1.5.
Yeah.
Okay. The only thing we have to be careful of is remember that your original curve was only a segment. It was only a small portion of the picture. It's not the entire line. So if you sketch it as a function and you see the whole picture, you got to remember in parametric it's not the whole picture. It's just a small part. Okay? So what you have to do is make sure you tell me if you change it to a function. Here's the formula, but x should only go from -1, what was it? -1 to 1. Okay, we shouldn't be sketching any x's that are above 1 or below -1. Okay? So we're going to do another one like that right now. Okay, and the important thing is to restrict the domain. All right, so everybody have this? If you need it, go like that. All right, so now this one says to eliminate the parameter. So we're going to do the same thing we just did, but we have to be careful with the domain. Okay, we're going to have to find our start point and our end point. Because when we sketch it, it should only be a small section of our graph. Okay, so what's the first thing I have to do with this equation to get ready to eliminate the parameter?
Solve for t for t.
Solve for t. Yep. So I'm just going to rewrite it. So it's t equals. And what should t equal?
Negative x minus 1. Or would you have negative x plus?
Plus. Yeah, just do a plus 1. And now what am I going to do with x plus 1? Plug it into t squared. So this one you're not going to have much simplifying to do. It's just, that's it. What shape is that if you graph it? It's a parabola and it's been shifted 1 unit to the left. So it's a parabola shifted 1 unit left. But it's not the whole parabola. It's only a small section of it. Right? So I have to restrict my domain. Okay? With domain, what letter do I care about, x or y? Just the x. Range would be if I asked you how high and low it's going to go. Okay? I don't really care how high and low it's going to go. I'm not asking for range.
So we have to find the start and end.
Yep. So how do we find the start point?
So
What number would you plug in for t to find the start?
0.
0. Okay. So if you plug 0 in, what's 0 minus 1? -1. That's the smallest value. And if you plug in, well, you tell me, what do you plug in to find the end point for x?
3.
3. We're not using y. Okay? Domain has nothing to do with y, so I'm not worried about that here. Okay, if you plug in 3, what's 3 minus 1? 2. So that is your answer. You'd be sketching a parabola shifted left 1 unit, but you would only sketch it from -1 to 2. Anything beyond that, you would just leave blank.
So x only,
Yep,
just for this.
Yep.
Trying parameter.
yep, that's all I need. Now, if I did ask you how high and low it's going to go, what function would you use for that?
What?
That would be your y values. What's the lowest value that y would ever hit? 0 squared. And what's the highest it would hit? 9. Okay? I'm not writing that because they didn't ask for it. But the highest value it would ever hit is 9. Any questions on that? Yep.
So you get your function by plugging your rearranged x into y, right?
Yep.
And then to get the domain, you just use the x.
Yep.
You plug in both of the parameters into x.
Right. You plug in the start point and end point of your interval for x, and that's your domain. Right? If you plug in the start point and end point into your y, that's your range. Okay? You do not have to give me the range unless they ask for it, but you do have to give me the domain. The domain must be restricted.
Can you explain the final part again?
This part? Okay, so to get your domain, okay, let's just write it down. Right, so to get domain, fill in the endpoints, or fill in endpoints of parameter into equation for x. Okay, so in our example, we had a 0 and a 3. So fill in those two numbers into the equation for x. In our example, we had, did I just say 0 and 3? Okay, and when you fill in 0, 0 minus 1 is -1.
0 for the first one, 3 for the second one.
Yep. And when you fill in 3, 3 minus 1, that's how you get 2. So it's kind of like finding the start point and end point of the curve, except you're only finding the x's. You didn't actually find the y's.
That would be your final answer.
And that, what I just circled, is your final
So
answer.
are we putting that in the calculator?
I'm not going to graph that one. No.
Okay. Oh, yeah, for the homework, we have to graph that?
No, I don't think they're going to have you graph. Not as a function. They'll probably have you graph it like this.
Okay.
They'll have you graph the
So we're
original.
not going to have to enter like math equation with the equal to.
Yeah, I don't think they're going to have you do that. Nope.
That's confusing.
Nope. I'm just showing you if you did want to graph it as a function, you have to type in all those parentheses. Okay? But on the test, if I have you graph, you're going to do it in parametric. You're not going to do it as a function. All right, so we've been able to eliminate the parameter in both of these equations. You can't always do that. Okay, there are some equations that are just, they're more complicated. You can't get rid of the parameter. But it is always possible to take something that doesn't have a parameter and turn it into one. So this is basically like turning something from a function into parametric. So this is the opposite of the way we just did it. Okay, let me take the equation I just circled, okay, this final answer, and let me show you a way I can make this parametric not even as complicated as the original. All right, if I wanted to make, let me just copy it over. What is it? X plus 1 squared. Let's see. All right, if I wanted to make that parametric, here's a very simple way to do it. For your first equation, just write this. X equals t. For your second equation, just take the original problem and change all the x's to t's. There's a set of parametric equations for this original problem. These and these, if I were to graph them, would look exactly the same. These are more complicated. These are a little simpler. All right, so to change something to parametric, your first equation is always x equals t. And your second equation, just change all your x's to t's. Okay, let's see why it works. If you have something in parametric and you want to change it back to a function, step 1 is take the equation with x and solve it for t. If I do that here, if I take the first equation and solve it for t, what does t equal? T equals what? It already is solved for x. Okay? There's nothing here to rearrange. Okay? It's not like one of these equations where you have to get t by itself. Okay? So you already have x by itself. Scroll down, maybe. And now you would take what t equals and plug it in. Well, if you plug it back in, you're going to get y equals x plus 1 squared. Right? So it changes it right back to what it was. Right? So that's kind of the simple, short way to make something parametric. Let your first one be x equals t all the time. And let your second one just change the x's to t's. It's kind of a cheap way to do it, but it does work. Okay. Right, so let's try it on this one. Okay. What would my first equation have to be? Yep, x equals t. And what about my second equation?
3
Yep.
to the 4th.
3
7
t to the fourth.
and 7t to the 3rd.
Mhm.
And then it will be t to the 2nd plus 2.
Yep, very good. And again, the reason why it works, take the top equation, get t by itself. Oh wait, it already is. Okay. Plug in what you have for t in all the spots for t. Well, all the t's would go back to x's if I did that. So there's a parametric set of equations for that. That's it. Again, it's kind of it's a cheap way to make something parametric, but it does work.
Is x always just going to equal t though, or is there?
Yep, for the first equation. Yep. I'm not saying this is the only way to do it. There's much harder ways to do
That
it.
was just it. It seems kind of easy.
But that's the easiest way to do it. Okay? In general, I would worry more about eliminating the parameter. Okay? On the test, you'll have 3 of those. I'm not going to give you very many where you do it this way. Okay? I really want you to know how to eliminate the parameter. This is introducing a parameter. It's the opposite. All right, so next graph we'll look at is a circle. And I think this will be the last graph that we actually figure out the equation for. And then I'm going to give you some equations, and I just want you to look at the different shapes that end up coming up. All right, so let's look at how we would do a circle. All right, so pick any point you want anywhere on the circle. Okay, just to make it simple, I'm going to do quadrant 1. Okay, and I want to think how I would describe that parametrically. Okay, parametrically means I have one equation for x and a separate equation for y. Does anybody have any thoughts what I'm going to draw here? And we've done it before. Yep, I'm going to make a triangle. Draw your hypotenuse to the origin. Draw that perpendicular. Okay, how long is the bottom side?
T, y, x.
X. Because this point, we went to the right x, and then how much up did we go?
Y.
Yeah, we don't know what it is, but we know it's y. And let's let this angle be t. Now, we normally use theta for the angle, but since we're doing it in parametric, I'm going to use the letter that we normally use with parametric.
Is t the hypotenuse?
T is my angle.
Oh, okay.
Yep. T is that angle right there.
Okay.
Again, we normally use theta, but with parametric, I decided to just stick with the letter they use. Okay, what trig function would involve x, t, and my radius of this circle?
Side and side.
We are going to use sine, but sine is opposite. What trig function has adjacent hypotenuse? Cosine. So cosine of my angle. What's the side adjacent to t? X. What's my hypotenuse? R. And now, if you got x by itself, how would you move r to the other side?
By R.
Yep. Multiply by r. There's your formula for x. R cosine of your angle. All right. What trig function would involve opposite over hypotenuse?
Is that fair?
What trig
Is
function?
that fair?
Oh, I'm sorry, t. Thank you. Thank you, Ubi. I get used to writing theta all the time for the angle. We're using t. So yeah, what trig function involves opposite over hypotenuse? Sine. What side is opposite my angle?
Why?
Y. Good. What's the hypotenuse? Over r. So anyone think they can give me the formula for y?
R times sine T.
T. Yeah. That's it. That's the equation of your circle. What do you think r stands for? It's the radius. Okay. And you want to keep those r's the same. Okay. If you make one r bigger than the other, you would get more of a oval. Okay. So now I want to use those formulas specifically to come up with the equation that has a radius of 2. Okay. So we'll just fill 2 in, and that's pretty much it. But
What happens like for the cosine of dx and for the sine of y, like in the equation below the part?
right here?
Yeah. Like
Well, when you multiply both sides by r, this is gone, and you just get r cosine t equals x. I just switched.
No, I just totally forgot the equal sign there. That's why.
So, can somebody give me my equations of a circle with a radius of 2? Yep.
X equals 2 cosine t, y equals 2 sine t.
2 sine t. Okay, this one I want to graph because I'm going to show you what t-step does. Okay, this is a real good one. If you don't have t-step correct, weird things happen. So go back to parametric. Okay, if you have anything in there, you can just type right over it. 2 cosine t, 2 sine t. And now, here, because we're using sine and cosine, anytime you use those, what do you have to pay attention to on your calculator? Yep, the t-min, the t-max, but
T-step.
something else too. Because we're using sines and cosines.
Oh, y.
T.
Something about our angle. What did we have to always be careful of? I said to check. Right. We can do it either way. We just have to check the mode, and depending on your mode, that's going to change what you put in for Tmin and Tmax. What does T have to start at and go to so you get a full circle?
0. Around 360.
Yep. If you're doing degrees, you do 0 to 360. What about if you're in radians? 2 pi. If you don't do 0 to 2 pi or 0 to 360, you're only going to get whatever part you do. Okay, if you did 0 to 180, you'd get half a circle. All right. Now for t-step, leave it at 0.1. Okay, that's okay. Okay. And I'll do it in degrees after just to show you how that works, but window should be fine. We're just drawing a circle with a radius of 2. Tmax has to go from 0 to 2 pi. So 2 pi. Okay, if you hit graph, you should get a nice circle. Now, it doesn't look circular because remember, the screen is wider than it is tall. if you want it to look the way it should, if you do zoom 5, it'll make it look more proportional.
Can you go back to the equation?
So those are my equations, and that's my window. The mins and maxes got a little funny because I did zoom square. Right, I'm going to show you same thing in degrees. Okay, let's go mode, change to degrees. Now watch what happens if I change to degrees and I leave it at 6.28. What do you think the Tmax should be at? If I'm in degrees, it should be at 360. Okay? I don't even think you're going to see the circle. It's going to sketch it from 0 to 6 degrees.
Yeah.
Well,
You really can see.
just started to see it, you can't even really see it. Okay, so set it 0 to 360. And there's one more thing you have to change. If you don't do this, your calculator is just going to get stuck. Change the t-step to 2. Does anybody have a guess what the t-step is?
Is it like the X and Y? It looks like it's moving. Like, it looks like it's on 2 for equating X on the negative y, and same for the y.
Oh, okay, I see what you mean. Yeah, it's that has to do with my radius. Anyone have another guess? The t-step has to do with the t-min and the t-max.
Like travel, how much he has to travel.
Right, it's basically how much it's traveling. Okay, so when I graph this circle, I'm starting at 0, and I'm going by 2s. And I'm graphing every single point till I get to 360. So I'm graphing 0 degrees, 2 degrees, 4 degrees, 6 degrees, 8, 10, 12, 14, 16, 18. So if I did something like this, 0.1, now it's going to graph 0.1 degrees, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1 degree, 1.1, 1.2. It's going to take too long. You're graphing too many points. Okay, if I do it, it's graphing thousands of points. It's graphing over 3,600 points to make that circle. Okay, you don't need that much detail, so I'm going to stop it. What do you think would happen if I went by 90s? Yeah, it's going to graph 0, 90, 180, 270, back to 360. It's going to graph 5 points, and it's going to connect them, just like I said, and it looks more like a diamond because it's only graphing 5 points, and it just connects them.
I got like a triangle when I put 2 for the t-step.
Yep, you'll get different. Look, now if I did
A full triangle.
if I did 45, it's going to be a little better. It's going to do 0, 40, 0, 45, 90, 135, 180. It's going to look more like an octagon. Right? So the goal is to try to find a t-step that's not too crazy. I think if you even if you went by tens and you graph all the angles 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, it's going to look pretty smooth. Yeah, that looks pretty good. Okay, but if you started to get any less than 10, it's not going to look right. Let's try going by, let's try 5s. I want to pick a number that doesn't divide into 360 evenly, just to show you. Let's do like 50s. So it's going to graph 0, 50, 100, 150, 200, 250, 300, 350. Can it graph 400? No, so it's going to end at 350. So you're going to see a little gap because the next one would be 400. So to avoid that, it's kind of hard to see. To avoid that little gap, use a t-step that divides evenly into 360. Okay, 20. 20 wouldn't leave you a gap, but I don't think it's going to look smooth.
You did the wrong thing.
Oh, I did the wrong thing. 0 to 360. Go by 20s. Actually, that does look pretty smooth. Okay, so even going by 20s, that's enough detail. Okay, but definitely don't go by 1s or anything. It's too much.
Yeah, mine's not showing that at all.
All right, let me take a look after and see.
It's old, right?
Yeah, it could be because it's the older one.
Okay.
Yeah. All right, that just takes a little work to play around with your t-step. All right, so notice on the screen, okay, the picture went from -2 to 2 and -2 to 2. But what did we have to use for the parameter? Let's say, what did we use in degrees to get a full? We went 0 to 360. That's very important. If you use radians, it was 0 to 2 pi. Watch what happens if you only go 0 to 180. What do you think I'm going to get? Yeah, it's only going to do half the circle. Okay, so you've got to make your parameter so it goes all the way around. And for a circle, it's 0 to 360. All right, so last thing we'll look at is I'm going to give you some equations. We're just going to graph them and see what they look like. All right, so just practice typing some stuff in. These almost look like the equation of a circle, except what letter is in place of the radius? A t. So in other words, the radius is changing. Right? So if the radius stayed the same, you'd have a circle. Let's see what it looks like when the radius is changing. Okay, so now we have t cosine t, t sine t. Does anybody have a guess what it looks like if you have a circle with a radius that's always getting bigger? It's a spiral. Yeah, it's going to spiral out. It's just going to get bigger and bigger. They tell me to go 0 to 4 pi. And if they're telling me 4 pi, that probably means we're in radians. So if you're not in radians, switch back. All right, and let's set our window, let's just try -10 to 10. If that's not big enough, we'll make it a little bigger. Yeah, try -10 to 10. T-step. What's a reasonable number to go from 0 to 12? In increments of what?
2, 4.
You probably want to graph at least 20 to 30 points.
0.5.
Yeah, I'd say 0.5 is perfect. Okay, because you're going to go from 0 to 12 by 0.5, so that's about 24, 25 points. It's a little rough. Spiral's not completely smooth. If you went by, I bet if you went by like 0.2, that would probably smooth it out a little bit. To me, that was a little smoother. And notice it goes off the screen a little. Right, so just make your, looks like your x min needs to be a little lower. And your y, maybe your x max a little higher. Okay. Any questions on that one? Y min, I think I should have made a little lower, but I think that's good. That's a complete window. You can see it's spiraling. Now, how come there's a little gap here? It probably should have made a full revolution there. What that gap has to do with what number in this window? The 0.2. 0.2 doesn't divide evenly into 12.56.
All of us.
All right, let's try try sketching that one. Okay, this time, x is 5 sine t, okay, and y is 5t cosine t. Just type it in. 5 sine t and 5t cosine t.
Does it matter if we switch to sine and cosine, or we usually look at cosine as bad?
Yes. Did I switch them?
No, that's on the problem.
Yeah, it does make a difference. Yep. Now, what's the What's the highest value for my parameter here? 20.5. Okay, so I'm going to set it from 0 up to 20.5. Now, let's think about our window a little bit. What's the highest sign ever goes? 1. And if you multiply it by 5? 5. So your x values are never going to go above 5. And what's the lowest sign goes? -1 times 5? Okay, so we're never going to go beyond -5 and 5. What's the highest cosine goes? What is it?
Isn't it 0.5? -0.5?
Not for cosine. 1. Sine and cosine are the same picture, just a phase shift of each other. Okay, so cosine hits 1. What's 1 times 5? And what's the highest t can go? They give me an upper limit on my t max. 20.5. So 1 times 5 is 5. Let's just do 5 times 20. 100, and just add a little bit. So your y max, it's never going to go above probably 105. What's the lowest cosine goes? -1 times 5? -5 times 20, -100.
Why do we use 20 for t?
Just because I can multiply that in my head easier than 20.5.
Well, I mean, like, why would we just because it's in the problem?
Yep, because that's what's given. And then I added a little extra.
But we don't use it for the x.
Well, there's no t in front here, so no. No matter what you plug in for t, if you take the sine of it, it can never go above 1. Sine of 20 is, can't go above 1, below -1. Okay, so hit graph, and we did a pretty good job with the window. Kind of looks like a watermelon maybe or something. Football. And that's it. Okay, so I just wanted you to practice finding the window. Okay, and last one. Okay, so try typing that in. And before you hit graph, try to think about the window a little bit. 5t minus 5 sine t. I'll put that back in a second. And 5 minus 5 cosine t. Now, this one, they don't give us a parameter. Okay, so you can pick whatever you want. Let's just try -20 to 20. Leave the t-step where it is. That's fine. Okay, what's the biggest that sine ever goes? 1. And what's 5 times 1? -5. But t, if we use the biggest value t can hit, what's 5 times 20? 100. And we said -5. So x, the way I have it set up, is never going to go beyond 95. All right, so try putting x at like 95. And let's try -95. And what about my y values? What's the biggest cosine ever gets? 1? What's 5 times 1? 5. And what's 5 minus 5? 0. Right? What's the smallest cosine gets? What's -5 times -1?
5.
Positive 5 plus 5? 10. So the y's are going to be between 0 and 10. Okay. And then hit graph. And basically, you just get these kind of curves, just same ones going along. It's just going to repeat like that forever in each direction. All right, so it does take takes a little practice to get used to how to set up these pictures and how to get the right window. It is kind of neat. Okay. This last shape, okay, it's the only one we did that has a special name. It's called a cycloid. Yep, the watermelon one, that had no special shape. I guess the first one was a spiral. But that one was called a cycloid.
What was the cycloid? The watermelon one, or was it the other one?
The cycloid is this one.
McDonald's arches.
Yep. Right, so tonight I'll just have you practice graphing a little bit and trying to eliminate the parameter, and we'll take a look at that tomorrow. All right, so the homework, it's on 481. It's a lot of just single problems, so it kind of skips around. Okay, 1 to 5. Actually, I guess I could have just done 1 to 11 odd, but I wrote 1 to 5, 7, 9, 11, 15, 17, 21, 22, 25, and 29 to 32. Okay, for ones that are on the calculator, just write down your x min, your x max, y min, y max, t min, t max. Okay, that's all you have to write.